All right. I just messed that up.
We have masks and all the
I
PPE and
did.
stuff, so technically, because now they consider an exposure unmasked if they do that. So technically, none of us are ever exposed unless you're in like a break room.
Right.
Keep moving this. Stay.
Like daily. I have several clients that are teachers and they're like, yeah, we're back to eating lunch in the classroom. But we're not supposed to distancing kids. Right? So, I'm like, what's the whole teacher being exposed every day?
Yeah. And there's some several counties that aren't even mask mandated for school. We're definitely seeing a rise in actual stuff.
One of my clients works at the current hospital. She said 20 out of the 50 beds are COVID patients right now.
Yeah, they just like, at Baptist, they just switched their unit to a COVID that's more like. And we are, I think we a 22-bed facility, and lately we've been having like 50 to 60 in the department, so the wait is just full for all of that.
Posted that when she went to the hospital, she was getting oxygen. She was sitting in the parking lot.
Of course.
And literally, just her chair, oxygen tank, and just sitting in the parking lot getting oxygen because there's only room inside for her.
Okay, we haven't gotten there yet. I was, I feel like I read something about that, they're doing that. I think it's in- that's not right, but somewhere, yeah, where they're like triaging you and seeing you like.
And I don't know what that was, so it could be anywhere in the US, but just from the different jobs that I've been all over. I mean, like, there wasn't anybody, she looked at a video, there wasn't anybody out there with her.
Were you wearing it?
Oxygen.
All right, so. And start again. All right. So if I put my hands in front of the sensor and then move my hands away, what will the graph do? I saw some people make a hand gesture to look like that. Let's find out if that happens. Now, I'm hoping that people can see this. Perhaps make it a little bit brighter here. They're slightly brighter. And I'm assuming all of you have better eyesight than I've got. All right, so let's try this. So we're gonna cover it up to start with. And then move away. And stop. It did not go up. Why did it go down?
Did you change the setting on the thing to make it a different direction, or the negative?
Yes, I did. So, when you were doing this last Wednesday, or 2 Wednesdays ago, whatever it was, why is the sensor registering positive when you put it in front of there? Yes. Most of you just said the answer is because we were in front of it, or above it, or something like that, but there's another piece to it. It's positive that way because it's set for that. You can make positive direction that way or that way. So just be aware. It's a minor point among all of it, but it's a point.
But there's no negative on that, is there?
That's negative right there.
Position wise?
So I had it set, so 0 is right.
Oh, okay.
So it was set, this was about 0,
So you can set 0 and then,
and make another direction negative.
okay.
Yeah. Just writing it down. All right, so let's start out with any questions. or continue with any questions. I guess we've already started. Okay. We last went through a problem, oh, and before class is over, remind me to actually hand stuff back. I had this last Wednesday and I had it on Friday and, you know, at this point it's become part of me, but I'd like to give part of it back.
Oh, we thought you just liked keeping us at suspense.
Yeah, no, it's that last step of the process of actually handing stuff back that sometimes flummoxes me. All right, without looking at your notes, you don't have to close them, you can just not look at them. The cake formulas.
VF squared minus VI squared. All over, is it T or is it A?
I think
If you're doing the
just
squares,
two.
which is it?
You don't put anything other than the 2 in the denominator, then you just subtract t. Is it subtract?
It's just multiply by 2, right?
Well, there's several ways of presenting it. When he did over 2, he's doing, presenting it differently than I've done in the past.
Oh. Well then,
You could
Yeah, I
do,
think you're combining two different ones.
oh,
you could do 1/2 VF, like minus VI, cause you said it's like the average of them,
Okay, so get rid of the squares.
I think. I'm not really sure. And then multiply by time.
An equation, they're equations.
It's equal to, V. What is
is it V average?
No.
Is it
Like-
acceleration?
No, let's think about units. This would be meters per second times seconds. What would I get?
Just meters.
Oh, displacement.
Yeah. All right, there's one other correction that would need to be made. When the squares got removed, we have to, indeed, as Brooke said, average, I think, or somebody up there said it. That'd be plus. Now, the one with the VF squared in it,
Mm-hmm.
I guess we're not ready for this yet. I
Um,
was hoping.
It's a Monday morning,
Yeah, well,
afternoon.
I know this.
I believe it's afternoon.
I know this one has acceleration in it, doesn't it?
Yes, it does.
And is it 1/2?
No, this is not the 1/2 one.
Okay. So
Alright.
it has to do with V initial, right?
Yeah. So typically I write VF squared equals VI squared and then something.
Right.
You said minus VI squared, so I thought, oh, okay, you just moved it over to this side of the equation, which is not wrong.
Mm.
Depends on what else you added. All right. Spoiler alert. So this is the one that has a 2 in it. There's a half that shows up here, and then there's a half that shows up in another one. The VF equals VI. Ooh, left the vector symbols off that. Someone should have called me on that. Plus AT, and then delta S equals VIT plus 1/2 AT squared. And I tried to make sure I wrote it as far away from you, Ray, as possible.
Okay.
All right, so let's run through another example before we start to make it more complicated. Oh, we'll do a simple one to start out with. A ball is dropped above a cliff, above an edge of a cliff. Above the edge, over the edge.
Like over the.
Whatever the word is there. As with any of these problems, if you don't immediately see it, let's go through the process. We got the 5 variables. Displacement, that's supposed to be an SO. I just preference X. VI, VF, A, and T. All right, what do we know?
That time is 3.7 seconds.
Yep, all right.
We
You know
have,
the acceleration?
Do we?
Yeah, it's gravity.
What is it?
9.87 meters per second.
Uh,
Square.
no, for 2 reasons.
Am I getting the wrong barrel?
You said 9.87?
Yeah, I did.
Yeah, 9.87, I'm not sure where you're talking there.
we have V final,
What's the final?
0.
Why is that not 0? That's a common mistake.
Because it's not slowing down to 0, it's just, it's the ground, so it's.
And what happens as soon as it touches the ground?
It bounces back.
Okay, not just the bouncing piece of it. But once it hits the ground, we have another element involved here. There's a new force on the ball,
And that's the ground.
which means the normal force from the ground. And that means my acceleration changes. And so we can't use those formulas if my acceleration changes. The language here of what's the height of the cliff or how long it takes to hit the ground below, we're actually solving for the height to that moment just before it's influenced by the ground. But that's not the language used in physics. You're just supposed to know.
Well, our V initial is 0 then.
There we go, we know that one. What's the key word here that tells you that initial velocity is 0?
Drop.
Yep. That's the key word right there. Now, Ian was close. I understand what Ian was going for, and he was in the spirit of correct. However, 9.87 meters per second squared is not a traditional value used anywhere. I'm sure there's got to be some place in the universe, but. But there's
9.8 meters per second. Per second.
So this,
okay.
this third variable that we need to like
Yeah.
use one of the equations, we're just supposed to know it, like the problem's not gonna give it to us.
Right, this is one of the reasons I'm doing this problem is that there's the understood bits of it.
Okay.
All right, so Ray went with 9.8 meters per second or 9.8 meters per second squared. There are 2 things that are implied by that. If I write down 9.8 meters per second squared, what are the 2 things that Ray is assuming?
We're on planet Earth.
That's 1,
That the acceleration's constant,
which means,
that it is not that, like, I don't know. It's constant, so,
oh, yeah, okay, then 3 things. Yes, we're ignoring air resistance. Acceleration wouldn't be constant if we're bringing that into it, in which case we can't use these anymore.
I'm assuming that average is somewhere near sea level as opposed to a higher or lower altitude.
Yeah, that's a, Earth average is 9.8 or
Right.
5 something. So, I don't have a problem with 9.8 per se. If this were a lab, I might ask you to use the Winston-Salem value and not the world average.
Right.
However, there was one other assumption here. See what Brooke was onto it and then she veered off.
No. It wouldn't matter that that's negative or positive, would it? Because it's still.
Well, there's an assumption built into, what is the assumption? That's it.
Positive direction.
By putting positive here, or making this a positive number, he is setting down as positive. And there's nothing wrong with that. So down is positive, as established. I guess you did a positive value too, so as established.
Just neglected to say the negative.
That's, no, we can make down positive, no problem. And this also assumes that we are somewhere near the surface of the Earth. you gotta be careful about that. On textbooks typically aren't gonna specify some other planet unless it is another planet. So if they don't say, then assume it's Earth. On tests, if I did a problem like this, when I wrote this up, I was thinking, of course this is Earth, or I actually was not thinking about the planet, I was just, inside me, I was, presumably, my subconscious was thinking Earth, but it didn't state it. If I don't, typically, you can assume it's Earth, and that's not a problem. I have had multiple choice problems where that is not an assumption you necessarily can make. So, if in doubt, ask. So it's above a cliff near surface of Earth. It's a proper noun. All right. So I'm asking for height. So what am I looking for? Okay, which equation am I using?
The last one at the bottom,
Okay. Why that one?
because you have, you draw the variables for that one.
Except for the one we don't know and don't aren't asked for. All right. So my delta x is equal to 0 times 3.7 plus 1/2 9.8 times 3.7 squared. So that term drops off. And we are left with, if someone would be kind enough,
This is 67.081.
anyone else get that?
Yeah.
Okay. This is that dramatic awkward pause as I wait for the answer to finish.
Meters.
That's it.
Yeah, that's correct.
Oh. It was not it.
All right. Suppose we had chosen up to be positive. So we'll do that in green. Let's make up positive here. What would change?
The acceleration,
All right.
so negative.
So if that did the case, we'd have delta x is equal to negative 67.081 meters. So what would be the answer to the question of what is the height of the cliff?
Well,
Either
it would
one.
be negative.
No, it'd still be the same because it's scale.
Yeah, height. I've never heard anyone, height is not a physics term, that's a everyday English term. What's the height of Mount Everest? No one has ever said negative, whatever the number is, negative 5 miles. Now, height is indeed a scalar, it's a positive value. However, math-wise, my displacement would be negative. All right, and again, part of the language we tapped on earlier, Liza?
Oh, so, we use the last equation, right?
Yes.
So, but that equation says, like, that solves for something else, like, what does that variable say?
That-
Like, what is, so what is next to the triangle?
Oh, that's an S.
So, if it solves, and that's changing speed, right?
No, speed is just a V without a vector symbol over it.
So, that is the same thing as displacement?
Delta S, delta X, delta R, delta Y, delta Z, these are all things that I could use
For
I-
displacement?
for displacement.
Oh, okay, that's.
Yeah, if you flash back to the notes when we first did position, I wrote up 5 different variables that are typically used. And S and R tend to be typically a little bit more generic. X, Y, and Z tend to follow along the math brainwashing, typically X for horizontal, Y for vertical, but it doesn't have to be, that's demonstrated here.
And wait, and the 9.8, for acceleration, that came from where?
From Ray. Now, the acceleration of gravity on Earth, if I take this marker and I let go, the acceleration is about 9.8 meters per second squared.
Alright, so that's gonna be given to us?
Well, you'll be using 9.8 that you don't need to look it up, but it should be on the top of the first page.
Okay.
So where you have, v final squared is equal to v initial squared, that's supposed to be speed, right, not velocity?
Correct, these are speeds.
Okay.
What is it?
Well, and so just to be sure, so those are the five, different things that like we have to make sure that we have, like.
Oh, these right here?
Yeah.
Yeah, these are the five basic, these five things are covered by all these equations, so if I know three of them, I can find the other two.
Okay.
And oftentimes, like the problem I did last week, I think all the three bits of information were given in the problem. This time, there's only explicitly one bit of information given in the problem, and the rest are things you're supposed to read out of it. Dropped means initial velocity is 0. Near the surface of the Earth makes the acceleration 9.8 meters per second squared because it's in free fall. If the only force acting on it is the force of gravity, then there's a value that you can use as approximation. You can pretend it's constant. Brooke?
Will we ever have to like add forces? Like, let's say the person, like the ball was dropped with a small force. Will we have to add that to gravity? And then like,
Well,
does that
Yeah,
make sense?
oh, chapter 4.
Okay.
Anyone else? All right. Oh, so how fast is it going at the bottom? Hint, the answer is not 0 in whatever unit you can pick.
I don't know, man. It seems like a good choice.
36.26.
How'd you get that?
The final velocity equals initial velocity plus acceleration times time.
All right, the third one I have over here. Yes, it's not. Ignoring that one. So the third one that's written over there, so we have V final is equal to, are you